Ported and
India
models.
offered engineering programs for working engineers and who completed their diploma programs and who completed their plus two programs.
ఏం కాంట్రోల్
Institute of Engineers in
అడ్డంగానే
India
రికార్డ్ అవుతుంది.
offered degree in engineering
వస్తుంది.
courses. Since then, IEA is paving way for learning for lot of engineering, practicing engineers and budding engineers and people at the help of the
ఇప్పుడేమో
affairs in
అడ్డంగానే రికార్డ్
engineering
అవుతుంది.
field. Initially, IEA has prepared lot of policy papers which were used by government of India for making lot of policies in the country related to various engineering areas. So you are fortunate to have being a student members of such a great institution, and we are having a good legacy of having a lot of great people who got degrees from this IEA,
రొటేట్ డివైస్ బ్యాక్
and
అని ఉంది.
many people got a membership in this professional body,
నొక్కాను.
which is catering its
తిరిగిందా ఏమన్నా?
services with almost 15 engineering divisions in our country. So to quote a few, you know, ISRO, present ISRO chief Narayanan is a student of IEA. He got his AMA degree and now he is elevated as a ISRO chairman. So all like that, Somnathji, who was earlier ISRO chief, is also fellow of the Institute of Engineers. And so many such people, stalwarts of technology, are either fellows or alumni of Institute of Engineers. There are few IAS officers, few IPS officers, and all the people who are working at help of affairs are related to Institute of Engineers. So why I am telling all this thing is, being you are budding engineers, so down the line you have to learn a lot of contemporary technologies. Institute of Engineers is providing platform for learning all such things. So this is one such program being sponsored by IEA, where the latest technology being used should be known to all the budding engineers. Why? Because you are the future leaders, you are the future practitioners of technology. So whatever you are studying in your academics, there may be having some limitations where you should understand the practical applications of our study, what we are doing, and you have to imbibe the latest technology where we are going to use, when you practice all this, your engineering profession down the line. So I am very happy that BVN is providing such ambience for many of the students who are studying EIT, and I am also associated in other programs with this institution. So you are fortunate to have such an ambience where you can get lot of new learnings. Why? Because unless you get equipped or acquainted with the latest technologies, your survival in the market, your survival in the industry is going to become a question mark. So you have to adopt new technologies and you have to get acquainted, or at least you should have a fundamental knowledge about emerging areas. So today we are living in a data era. So without data management and without data in every field, so the efficiency, we cannot make the system use effectively. So one such thing is we are using big data, and big data is nothing but basic component in every field. So here we are going to discuss today about smart grid, and in the smart grid management, how this data is going to be managed, how we are going to use effectively the tools, the technology, latest tools in managing this, and how it is practically going to happen. So we are very fortunate to have today's chief guest, who is having a lot of experience in this grid management area. He has seen the complete transition from conventional mode of grid management to the today's smart grid management, and he will give a lot of insights how the things are happening. And also we are having the good resource persons. Engineer Santosh Dar is there, and Abhinandan is going to speak on these various issues related to this latest technologies and application in this specific area of grid management. So please keep in observing all the things, make note of all the points, and have a good learning And whenever you go for any interview, you can proudly say that you are good at this thing, and you learn something from various programs like this. And when you quote this, definitely you will be one amongst the selected people, those who are having acquainted with the latest technologies. So I wish all of you a good learning from this program. So which is our intention of our institution of engineers. All the budding engineers should be good at new things, learning new things, and they should showcase their proficiency down the line. So wish you all the best, and I thank once again UAT for providing this opportunity. And I have a
Thank you. Following that, I would like to invite Mr. Y. Mallikarjun Reddy Garu to address the gathering.
So good morning, dear students. Today's chief guest, Dr. Srinivas Kavadar, Chief Engineer, APS NDC, the India Border, and our chief guest of honor, Dr. M.N.S. Chairman, Iei Apsc, and Head of Department, Dr. Naresh Babu, Honorary Secretary, and the faculty members and the students, and also especially the coordinator, Mr. Kalyan, and the faculty who are present here. So as you know that the Institute of Engineers is one of the chapters we are running in our college from the beginning, and successfully we are conducting many events, right, for the faculty development program and student development program. So in which many students are benefited, right, by doing various activities under the Institute of Engineers. So as you know that it is gives the teamwork, right, to do the internships and projects, right, and the latest technologies and innovations. So as a part of that, in association with the Institute of Engineers, and we are conducting this one-day workshop on big data analytics for smart grids, challenges and opportunities. So you know you are the final students of BPE, right? So big data analytics is one of the subject that is present you are studying, right? So what is how it is related to smart grids? So most of you know what is a smart grid, right? So the grid connection is very, very important for that the transmission of the power, right, from the power generation to the users. Right? So there is a lot of opportunities in that for the electrical students, right? And we have a lot of demand also because we can find out a lot of opportunities and challenges in there, right? So as you know that when AI technology is introduced, artificial intelligence, right? So by taking the data, like from the, then we are facing a lot of challenges. So what are the challenges that we are facing? So because of increasing the facilities and competition, the power generation, right, and utilization of the power, and how effectively you are utilizing the power, and how you are going to connect. And you can see that what are the different types of the power generation, and how to store the power, right, and how to utilize it more effectively. So there are the many challenges out there in ways. So especially we have seen that the renewable energy system, you have the solar power, the wind power, tidal power, and have the different power energy generations, right? But how you are utilizing them, how to connect them to the grid connection, then how to save the power, that is the storage system. So nowadays there is a technology that is the battery manufacturing. Right? So previously the battery cost is very high, but now it is reduced. And the cost of the battery is getting very less amount. So then the solid state batteries are available with nickel cadmium, right? And iron batteries are there. And recently we are going for the green energy system. That is hydrogen cells, hydrogen cells, and that also going to use in the electrical vehicles. So the batteries are used in the electrical vehicles, the storage of the power, right? And how you are going to utilize them. Right? So here is a lot of challenges how effectively we are going to store the power. Right? So there is that energy battery storage system. Energy battery storage system, that is EBSS, one of the new technologies that is came right. And in every power stations, right, we are going to put EBSS as the battery storage system. So where the energies are coming from the different sources like in the power, solar system and the wind energy, wind generation, and all those things. The power is stored and we can utilize whenever we want. So that is connected to the grid connection. So therefore the transmission, generation, transmission, storage and utilization. So where you can find out what of the problems, what of challenges are there. So you can explore it. You can see that you can find out the different the solutions also you can do that with the AI technology. So when you are adopting and artificial intelligence and machine learning, deep learning technologies and using the cloud internet connections. Right? So because this is not only for the electrical engineering student to do that. So because we have to learn the many technologies from the mechanical engineering and computer sciences subjects also can be learned. Right? So thereby we can increase the information power that you can make many innovations. Many innovations. So therefore, especially what we think that suppose if you invent a small device, right? So it is gives more energy generation, energy storage system on the battery, uses the right? Whatever it is not. So there is a lot of opportunities are there, right? Just you can think about and learn the subject and see what is the request of the student, right? Take up your final year projects on the green technologies, right? And artificial intelligence, machine learning, and how we are going to use for the energy storage system, right? And also energy transmission, right? And because this is a very important question, right? You can find out the many job opportunities in the manufacturing, right? So solar modules, manufacturing of the solar panels, solar modules, right? And the battery system and battery modules, and how it is going to connect to the grid. And also there are the different types of regulations, energy regulations, then optimization of the power optimization. So when you take any system of that, suppose for example, we take our entire campus, right? So how to decrease the power wastage? So that also you can do that. So how to reduce the power wastage, right? And how to increase the efficiency of the creation of the power. So there is also many challenges we are doing. So take up this as a project work and do it. So for which today's workshop is very useful for you, right? You can think in the direction and learn more techniques, right? And take the fiction. Okay? Thank you.
Thank you, sir. It is my profound honor to introduce our chief guest for today's seminar. We are exceptionally fortunate to have you with us, a truly visionary and preeminent authority in field of power transmission, Dr. Srinivas Kavaturigar. It is my proud privilege to introduce the chief guest for today's one-day seminar, Dr. Srinivas Kavaturi, Chief Engineer at Andhra Pradesh State Road Dispatch Center, APS LDC, Vijayawada, with an illustrious career spanning over 35 years, handling energy settlements across Andhra Pradesh power transmission network. An academic at the heart, he holds PhD from Sri Venkateswara University in Power System Reliability and MTech from IIT Kharagpur and a BTech from SPU College of Engineering, awarded with the Indian National Merit Certificate. Throughout his career, Dr. Kavuri has held various pivotal roles, including Chief Engineer of Kalapaju, Managing Transmission Infrastructure, Kadapa, Kannur, Anandpur, and Chittoor. He also supervised O&M operations in Nellore, Ongole, and Prakasam districts, overseeing 220 kV and 132 kilowatt substations and relay protection systems. Earlier, he was involved in high voltage operations and testing across more than 20 substations, particularly in Chittoor and Nellore regions, and played a key role in commissioning of systems at PDPS and KTPS, working on SCADA, turbine interlocks, protection relays, and control equipment. As divisional engineer at Vidyut Savda, he oversaw major power projects like Handri Nivasudala 73, Galleru, Nagari, Alisagar, and Devadula, handling AI in forecasting and transmission optimization. Recently, he completed a postgraduate from Artificial Intelligence for leaders from the University of Texas at Austin and Great Lakes, India. Expanding his work into AI-led decision-making, predictive workforce, analytics, and energy modeling. In addition to his professional milestones, Dr. Kavuri has worked on AI-based projects involving e-commerce sentiment, analysis, employee attrition, prediction, AI team structuring, and HR finance automation. His unique blend on ground engineering excellence, academic achievements, and technological vision makes him an inspiring figure in the power sector. Srinivas Kapturi, with a warm round of applause.
Respected please under Professor Dr. Iei Apsc, Convener and Entrepreneurial Congress Secretary, Iei Apsc Center, Dr. Suresh Narasaikal, Advisor, PBITU, CES Student Chapter, Professor Dr. Nanalas Devakumar, FI Chairman, Iei Apsc Center, Professor Dr. Y. Mallikarjuna Triga, FI, Registrar, Iei University, Professor Rambabu Kodani, Vice Chancellor, Iei University, Vasudeva Chancellor, Iei University, and dignity on the after as my senior colleague, Kesavacharya, retired chief engineer, my predecessor on grid management, my standards and other faculty members. I believe it is a great pleasure and privilege to address you on the occasion of one-day workshop in big data analytics for small business challenges and opportunities. So coming to the subject, electrical engineering and three core subjects. They look as if they are getting backtracked, but still they have their own significance in public domain. So I don't think we need not worry about the future of these fields. They will have their own standard progressive outlook in the coming years also. The addition of latest technologies like as earlier our speakers told you, utilization of these tools like big analytics, big data, machine learning, artificial intelligence, in field of application, mechanical engineering, almost all fields are used. So domain knowledge is AI. That is going to be the game changer in particular future of all of our units in both subjects also. Coming to my field, electrical engineering, because I have been in this field for a period of 35 years. Saturation is there in electrical engineering, no doubt, because power systems and machines. These two subjects are actually used to be very tough and saturated subjects earlier, but electronics got added into these fields, and again, that this became electrical and electronics engineering. Now, actually, this is electrical, electronics, and computers. Almost without this AI, the survival of any branch is very difficult because technology is changing. Earlier we used to have only thermal and hydro units for grid management. And we used to be very comfortable in managing the grid because you know the demand. Demand is known to you, generation is available. So generation is more, demand is less in olden days. So managing the grid used to be quite easy. But over a period of time, with the development of this factory, the demand also started rising rapidly. And we ramped up generation also in thermal units. Earlier we used to have 60 megawatts. 60 megawatts went up to 110, 110 went up to 210, 210 went up to 500, 500 went up to 660, 660 went up to 800 megawatts, single unit. 800 megawatt single thermal power plant is really a miraculous one. And the technological perspective, it's a very big unit. So we kept on raising the individual generating sectors. So suddenly we started using more coal. So suddenly the emission of gases. So the environment started getting polluted. So the thermal plants emit NOx and SOx. These gases are harmful to the general public. They pollute the atmosphere. So suddenly there is a climate change, etc. effects are there. So people and policy makers are worried about the environment. So global temperatures are rising. Global warming is a reality now. We are experiencing a lot of pollution in the atmosphere. So there is a need for change in the technology as far as power generation is concerned. So a lot of research development happened throughout the world in almost all top institutions, and there is a revolutionary developments in solar and wind generation. Earlier, solar and wind used to be extremely costly, expensive power generation used to be costly, but now slowly solar power and wind power they have come down. Per unit almost to 3 rupees 40 paise, and thermal is rising because coal prices are rising. So because of that, now it is cost effective to go for solar and wind generation. So people started thinking in those directions, and they started developing these technologies in large scale. So with the advent of these new technologies, the grid management has become so difficult because we stopped developing thermal units. Hydro units, it is very difficult because we need to have water source. So again, there is a bottleneck because we get only solar and wind almost only in the data we will get it. So base load has become a big problem because only solar and wind, it is very difficult to manage the grid. Our demand right now is around, it is very between 10,000 megawatts to 4,000 megawatts. In terms of million units, they are anywhere between 190 to 260. That is quite abrupt and instantaneous. It will grow rapidly and will fall rapidly. The demand is extremely volatile. So managing the grid has become so difficult because of the intervention of these non-conventional energy resources. Actually, there is a mix of both these conventional and non-conventional. Conventional is, as you know, hydel and thermal. Non-conventional is solar and wind predominantly. So we started mixing these two things. So market operators have entered into this. Most of the solar and wind generation is happening in grades only because it is extremely capital intensive. Governments cannot spend more money. So all solar and wind generators, they are being developed by only pure players like big companies like Adani and Ambani. The top companies are coming and investing in solar and wind energy. So buying their power, managing their power, so power economics and market operations, that is a major area now. We have to manage the grid with cheap power. So always we have to keep in mind the general public where we cannot charge more money to the public. So buying power is to be based purely on economic scale. We have to avoid buying costly power. We have to buy economic power only, so that the cost to the end consumer will be minimum. So here we encounter a big problem. So that's why we are using technology. Using of software is almost inevitable and compulsory. In view of the cost aspects of this buying and selling power. So power is sold by generators, power is bought by say independent system operator, ISO like APP transport. We have a separate team, APPCC. So they will see the commercial operation of the company. They keep on tracking the prices of the power. Where we will get low power, they will buy it on continuous real-time basis. It is nothing but a real-time market. In the real-time market, we keep on observing the price of the power supplied by the developers. There will be bidding. So we have got 96 block periods in a day. 24 hours, we usually do 4. So 96 blocks. So if you take from 00 hours to midnight, 00 to 0050, 0050 to 0030, likewise, there will be 96 blocks. The price will vary for every block. In the night, there will not be any demand. We have demand only morning 6 to 10, again evening 6 to 10. Because of lighting load, because of basics, nighttime load is going down. So, why this technology? Because we want smart grid. Earlier, we used to send power from generation to transmission, transmission to distribution. That is a normal grid. In smart grid, we have power flow in one direction, data flow in the reverse direction. So, we want consumer data, consumption data. Consumers, SC consumers and LT consumers, and their utilization pattern. That is very important. So we are trying to store the data. Day-wise and hourly data is being stored, and the data is nothing but your big data. Because we are getting a lot of data, terabytes of data is being stored now. India a bit lagging, but in foreign countries, big data is almost playing a vital role, and we are also catching up. So we are also building data centers. And this data center concept is quite new to India. It is very costly, but now it is coming up. In South India also, in Amravati, people are trying to put data center in Hyderabad, Telangana, and also in Gujarat, in certain places. Now, usually earlier we used to see STD booths like that. In future, we will see data centers. So many data centers are going to be planned and commissioned in the coming days. So data is going to be a vital part in almost all areas, engineering, any engineering, civil, electrical, mechanical. So these computer engineers, they will do a bridging gap only, because data is relevant to all engineering branches, irrespective of its nature. So that's why today's topic, big data analytics for smart grids, is really a challenging topic, which is going to be dealt throughout this day by various industry speakers. So, with my knowledge, as of today, we started using almost for data for weather forecasting in real-time basis. These models are to be tuned continuously, because load forecasting is a tough topic. We need to have a correct weather model to predict future demand. So we are doing in our state load dispatch center, we are also using different softwares for load prediction, so that we can buy power and sell power. If we have excess power, we will sell power. If there is any shortfall in power, we will be buying power. So these operations are extremely dynamic. So we need to keep in mind general public's sentiments to keep their energy bill possibly to a minimum. So government is that way encouraging rooftop solar. Rooftop solar is very important for almost all households to go for rooftop solar to reduce burden on the grid, and also to get individual benefit from this solar energy. India is lucky to have, I think you have almost 280 sunny days for every year in Vijayawada, Ongole, Prakasam, Ongole, Delivery, etc. In South India, in Andhra Pradesh, you have almost 260 to 280 sunny days. So you can generate power using solar panels on your own rooftop, where you become a producer and also consumer. The new term is a prosumers. You consume in the night, you produce in the daytime, so you are a prosumer. So that concept is picking up right now. So people are also getting benefited by putting solar panels on their rooftops. Big institutions like VVIT, they are also going for 300 kilowatts AWP solar power for reducing and optimizing their power consumption. So it is beneficial to the organization and also to the individuals to go for rooftop solar continuously to get benefited from the sunny days. Because India is blessed, we get a lot of sun. So solar energy is a blessing for South Indians. So I request all of you to educate your parents and to put rooftop solar on your household roofs, so that there will be a lot of reduction in current bill and also reduction in the grid demand also. So with this, I conclude my topic and I congratulate this institution and also giving me an opportunity to speak before you about this good topic. Thank you.
Thank you, sir, for your insightful overview on big data analytics for challenges and opportunities. Now I request our beloved principal, sir, Y. Mallikarjuna Reddy garu, to felicitate our chief guest, Dr. I request Kesava Rao, sir, to address the
Good morning, all of you. Good morning, sir. The chairman of this university, principal, and other great students. So, the introduction for the
Thank you, sir. Now I request our beloved principal, sir, Y. Mallikarjuna Reddy garu, to felicitate our chief guest, Sri Dr. Srinivas Kavaturi garu. I also request other dignitaries to join.
Hello.
Now we would like to invite all the faculty members and IEI volunteers onto the stage for a group photo.